Okay, hi folks. We're going to continue our videos with the expected value of a random variable. This will be one of the last videos or content videos in probability. And let's take a shot of this. This is now expected value. What is this? This is actually synonymous or the same as the mean, okay, of a random variable. So when you say expected value, this is just similar or actually the same as the definition says that it's the same as the mean of the random variable. So it gives us a measure of the center of the distribution of a variable. It may be also thought as the long-term average value. So try to imagine if you're going to create or recreate this random experiment, what is your expected value? Or that is, if you're going to continue and do the experiment, the random experiment for a long time, for instance, as we do the experiments with more and more and more trials, we will get to we will get closer and closer and closer to this expected value. Okay, this is the long-term average value. So in the field of investments and business, it is what we call the anticipated value for an investment. So at some point in the future. So definition. The mean or expected value, again, it's similar to it's the same as the mean, but let's call it expected value so that in business sense we can have that grasp. The expected value of big X is equal to the mu. That's just the Greek representation of the expected value, or equal to the E of X. That's your sample other description or other denotion, is equal to the summation. Notice, is equal to the summation of all the small x's in big X, okay? All the values of the big X times the probability of that particular small x that you have. So small x times the probability of that small x, sum them all up, and that will be your expected value. So that is expected value of a random variable big X is the sum, okay, of the products of all your small x's and the small x's corresponding probability. Okay, so let's have this example here. So let's go back to our example in the 2,000 children. Okay, I mean 2,000 families. Okay, they were asked about the number of children they have. So let's try to have the expected number of children in this family. So how do we do that? Again, our formula is the summation, or rather we can make use of the letter e of x here. So e of x is equal to the summation of all the x sub i's. Anyways, x sub i's for all i's as far as big X is concerned. Um, Small x sub I times the probability of this small x sub I. Then get the sum of them. Okay, so that's our formula. So the next line we'll have is this. Okay, so wait a hold up. Let's try to explain this one by one. So we are considering all x sub i's and then our probabilities of that certain x sub I. So our x starts with the 0. So this is we'll call this our x sub 0, and we'll call this our p of x sub 0. Okay, so notice we can find it in the first term in this here. So this is the p of x sub 0, and then this is your p of x sub 0. This is your x sub 0 rather. And then we continue with your x sub 1 found here. Multiply that with its probability found here. Okay, and then we add that with the x sub 2, it's found here, and its corresponding probability here. And then we continue the process. 3 found here, multiply that by its probability, just found here. And lastly, um, x sub 4 here, and then the p of x sub 4, which is found here. And then we're going to find the product of each of the groupings. And then what we have is 0 for the first, the same as the second because multiplied by 1. Next is here, here, and here. And then what we're going to do is we're going to add them. Okay, we're going to add. The process here is similar to getting the weighted mean. You may think of this as these is the values of our means, and these are the weights. You may think of that like that, but this is very average. This is very much similar in get finding the mean, the arithmetic mean, or in particular the weighted mean. Okay, when it has weights, so that we multiply it for each of the weights, and then after that we sum. That's what we do in means, right? We get the sum, and then the sum is 2.14. Or, since we're talking about the number of children, so it's 2.14, we need to round that off to become 2. So this expected value that we can, since we don't have point 0.14, a point 0.14 child, right? So this is going to be rounded off to 2. So what can we say? So in the long run, on the average, okay, a family in this particular town, in this particular setting here, in this location, has two children. Okay, so that's what the meaning of the expected value is. So on the average, if you're going to interview or survey someone, okay, in a family, okay, in this particular setting, on average, or the expected number of children that you'll have, that you will have in that certain interview is two children, or that family has two children. Okay, so um, we will have another example that's referring to the die, to the throwing of two dice rather, a pair of dice, and then we're going to show that in the next example. Okay, and in this video, we have just ended with random variables and probability distributions. That's part 5 in our batch of videos in probability. Okay, so again, my handouts are taken, or the content here are taken from the handouts by Dr. Sweet Rose Linares. So thank you very much for watching. There will be an example too, which will be soon uploaded, and kind of wait for that. Okay, so don't forget to hit the subscribe button too, so that you'll not get the updates. Okay, so thank you very much.